command if you see me type that. So what I've got running here, what do we have here? This is a terminal window where I'm in the Gitaly project, deep down in GitLab development kit, in this nested directory. And up here I have a window where I'm in the GitLab subdirectory. And over here I have a GDK run process running. And I wanted to start by looking at GDK run at that process tree and see what's in there, because it gives us a sort of overview of the backend of GitLab and what the different parts are. So let me look up the PID of that process. So now I need to use U. So the PID of foreman is that, and if I PS3 that, then we get this. Is this readable? I'm going to.
Yep.
Yeah, okay, I'm going to assume yes. So here's a process tree of everything that GDK spawns when running GitLab. And actually, there is something missing. We'll get to that in a moment. So what's going on here? Well, this obviously is Postgres, or actually this whole bit. So let's separate out that. And then here's Gitaly. We sort of know what that is. Here's Workhorse. That is a thing that stands on its own. Then there's Sidekick here. This node process is unique to development, because in development we have Webpack doing something with live recompilation of the JavaScript assets, and so you don't see this in production. And I won't be talking about that at all, because the GitLab JavaScript frontend doesn't talk to Gitaly directly. So I think we can ignore it in this discussion. Then we have Unicorn, and Unicorn sort of belongs with Sidekick, so I'm going to move it up here. And then down there we have GitLab Pages, and these things, yeah, ignore what this is. These are placeholders for Docker registry and object storage, which are not enabled in GDK by default. And up here we have Redis. Maybe I should move that a little closer to Postgres. So Redis, Postgres, Gitaly, Workhorse, and then this is, let's say this is Rails land, and this is database land. And then there's Workhorse, and what's missing in this picture, I'm just going to other front ends. No, let's just call that front ends. So there's Workhorse, and missing is SSHD, which is the SSH daemon, which you run into when you do git clone or git push or git pull over SSH. These two are interesting, and these two are Gitaly clients, but I propose we don't go into these because they're just added complexity, and most of the interesting client stuff happens over here in the Rails part of GitLab. Any questions so far? Is this picture making sense?
Yeah, this is helpful.
Makes sense.
I know that GitLab Shell, is that part of the Rails app, or because I've seen that places?
Good question. Spawns, so SSHD spawns one of GitLab Shell processes. So
I see.
You would never see GitLab Shell in a process tree because the processes are one-offs, but they get spawned by SSHD. And so one way to think of GitLab Shell is that it's an adapter between SSHD and the rest of GitLab.
I see. Okay, cool.
Another thing that's missing here is Nginx, although you can mostly ignore the role it plays in GitLab. So yeah, let me talk about the HTTP stuff. Unicorn is a Ruby HTTP server. It's a rack server. This is a standard for Ruby web apps, and it's pluggable. We could be using something else than Unicorn, but Unicorn happens to be what we use in GitLab. And we've been using it for so long that we tend to confuse the Rails web server processes with Unicorn, because Unicorn happens to be the name of the happens to be the actual process that hosts the Rails application. But yeah, in some ways the architecture of Unicorn is relevant to what we're doing, but most of the time it's something you can ignore. We're doing experiments to replace Unicorn with Puma, which is another Ruby web application server. I don't know what the status of those experiments is. That's a separate topic. But yeah, I wanted to point this out because really this should be, you should think of this as web. And this is background jobs. But the actual programs we use to do that are called Unicorn and Sidekick. So people tend to talk about Unicorn and Sidekick around here all the time. But those are, yeah, I guess they're brand names, and that's not their actual generic purpose. It would also be possible for us to replace Sidekick, but there are no plans to do that I'm aware of. Yeah, so one more word about Workhorse. Workhorse is a weird concept that's a bit unique to GitLab. It is a reverse proxy that sits in front of Unicorn. So it's actually tightly coupled to Unicorn, and every request that reaches Unicorn, almost every request, goes through Workhorse first, and Workhorse modifies it or does its own little stuff with the request if it feels like it, and otherwise it just passes it through as a reverse proxy back to the web, the Ruby, the Rails backend, and then also the response passes back through Workhorse. So there's complex interactions going on between this and this that are a later topic, because Gitaly actually has a role in this.
So Workhorse will directly talk to Gitaly in some cases?
Yes, exactly. But Workhorse doesn't know anything about where Gitaly is. So every time it talks to Gitaly, it has first talked to Unicorn to hear what Gitaly server to talk to and what to do. And these interaction flows are, if you're a Gitaly contributor, at some point you're going to run into this, and it's our job to know how this stuff works. But we're going to ignore that for now. And go back and focus on the Rails app. So for whatever reasons, I don't really know how to explain this if you're new to Rails, but these things live out of the same code base. So the GitLab CE repository, GitLab.org/GitLab CE, is the Rails code base plus the front-end code base. But so in there is a big Ruby application with lots of files, and both of these things are processes that load that entire application into memory. And so they share a lot of code. Both of these directly connect to Redis and to Postgres. So all that stuff is clustered in what we call the Rails app. Okay, I'm making this up as I go along. I haven't planned this. Do you have any more questions about this high-level picture, or shall we start looking at the Rails code base?
I think we're going to move forward.
Yeah, then we're good.
Cool. Okay, so this is my window with the Rails code base. So how does this talk to Gitaly? Now there's two ways to look at it. We can look at the configuration data, or we can look at the actual Gitaly client. You want to start with the configuration or with the client?
Configuration.
Okay, cool. So the main configuration, almost all configuration of this Rails application is in a single YAML file in the config subdirectory, and that is this gitlab.yaml file. It's big. Actually, a lot of configuration these days is in the database, because this YAML file is stored on disk on your application server, and the Rails process is not allowed to edit this file. So I guess nowadays this is more sort of bootstrap configuration. So this is stuff that the application needs to know before it can even boot up. But after that, we try to store as much application as we can in the database in the admin control panel of the web application. In case you haven't seen that, I have the app running here. So if I sign in, it's going to be a little slow because I have an old laptop and this is development mode. It's probably slow for everybody, no matter how fast their laptop is. I want this thing to load, and then I want to show you the admin panel just so you know what that is. But because the other way to think about the different types of config is that some config will be constant. The config that's in the admin panel is stored in SQL, and that will be included in a backup. And when you restore from a backup, you might be in a slightly different environment that looks different. So any config that you can reasonably expect to be different after a restore should not be in the admin panel, because otherwise you can end up with a catch-22 where you can't boot the app because it is making assumptions about its environment that are false on your new GitLab server. So let's see, where's the admin panel? That's this one. And this thing has, okay, no, things are a little faster. This has a settings area. Where there's some stuff we can configure. What's general? Funny, we have general and we have preferences. Oh, this is general. Repository. I don't understand why these buttons are different from. Oh, general is broken down into these areas. So here is stuff about repository checks and housekeeping. This is actually relevant to Gitaly. And somewhere, maybe it's in general, are the Gitaly timeouts. The default timeouts that get applied to Gitaly requests made from within a web context. But this doesn't sound account and limit. That is not it. None of this sounds like it's it. So what's preferences? Oh, preferences Gitaly. Here we go. Here we have a little bit of config, and this is stored in the database. And I think the way to look at this is that if we can get away with storing it in the database, we do that nowadays just because it makes it so much easier to apply to config changes on gitlab.com, because otherwise you need to edit a config file on disk on every application server and restart the application, which is a major hassle. In the case of Gitaly, go ahead.
Sorry, Jacob. So configs like this, does it just get loaded during startup?
This gets, I think this gets loaded once. I think this gets loaded during the request.
So the timeouts here, it means that the caller is going to cancel the request within that timeout. It doesn't mean that Gitaly is going to terminate the request if it senses that those timeouts are exceeded.
Actually, both. gRPC allows you to set deadlines on calls, and if I've never checked this, but the way I understand it, those deadlines can then be enforced by either the client or the server. But Gitaly does not set its own deadlines. By default, there are no deadlines in Gitaly, and if there is a deadline, it's only because the client asks for it. So we have a fairly trusting, permissive thing going on there.
Okay.
Yeah, to go back to your question, John, I think we reload config from the database on each request. So if you make a change, then it should probably start having an impact from all requests after the change is committed to SQL.
I see. Okay.
I think, I'm not super sure about this because I'm not active in this app, part of the app a lot. So this is one part of config, but as far as Gitaly concerned, this is kind of small. Although there is one other important part that we can maybe see if we go to the projects, we can use this as a sort of poor man's SQL browser. Here's a project. Oh, and there's a thing called Gitaly servers here. We've got to check that out next. Gitaly storage name. So this thing is corresponds directly to a field, just a text field in the database. So each project record, there's a column called storage name or storage. No, it's called repository storage. And that has a string in there, in this case called default. And this somehow will get mapped to a Gitaly server, which is maybe, which I think is one of the things you wanted to know about, Paul.
Yeah.
Yeah. So we'll get to that, or I want to get to that while we're looking at this. Yeah. So each this is an important part of config as far as Gitaly is concerned. Every repository belongs to a project. This actually goes as far as that repositories used to or still don't really exist in the SQL database anywhere. We just have records of projects, and implicitly each project has a repository attached to it. So looking up a repository starts by looking up a project and then saying project.repository, and then you get your repository. And every project actually has two repositories because it has a normal repository and a wiki repository. And these things in the data model, they just hang off project, which is, I don't know, I guess that just happens with your data model. I mean, if you look back, maybe it doesn't make sense, but that's how it happened and what it looks like now. And I think there are some efforts to actually make repositories first-class citizens in the database, but I don't know how far those are. Okay. And you can do a transfer repository check. We're not going to look at that now. Let's look at the Gitaly server, see what that does. So this is actually the mapping we were talking about, Paul, where we want to know how does the storage name relate to a network address. And this page is generated from data in the config file. So this is actually data that is written on disk on each GitLab application server. There's a config file that needs to have this same mapping. If we would have more than one Gitaly server, there would be a list here. But by a minimal setup has only one. And we mandate that there has to be at least one Gitaly server with a storage named default, or the application won't boot. So you're likely to see this default thing one place or another. Another thing worth noting is that this thing is on a Unix socket. That is because Unix sockets have some nice properties for this stuff. You don't have to worry about port clashes, and it's easy to restrict access using directory permissions, so that only I think this one is not very restrictive because I suspect this directory is open. But in production, in a standard single server production installation, this socket would be in a directory that has mode 700, and that nobody except the application user can see its contents, and hence no one can access the socket.
So Jakob, if someone adds another Gitaly server address to the configuration file and reloads the server, does it just start round robin rotating between the Gitaly servers for new repositories, or does it balance the existing repositories? What happens when you add another?
Good question. I think default, this is, now we get into community edition versus enterprise edition territory. I think in GitLab community edition, nothing happens. There is, so maybe I should have booted enterprise edition, but I don't want to do that now because then we're sitting here waiting for 5 minutes for the whole thing to boot. But in enterprise edition, you can designate which repository servers, which storages get used to create new repos. And this is a very, very bare bones mechanism. that just does just enough for what we need on gitlab.com and nothing more. Because what happens on gitlab.com is we notice that we're running out of disk on our existing Gitly servers. We instantiate a couple new ones, and then we configure the admin panel to say all new repositories will be round robin on one of these 3 new ones. And then at one point the dashboard says, oh, our disk is full on these 3 new ones, and then we start over again. I think this is in the docs. Just look for a moment. Storage. Yeah, so this little panel exists in Enterprise Edition in the admin panel somewhere, but not in Community Edition. And there you can click. It's a select box where you can click multiple entries, and then all new repositories get round robin over those new servers.
So storage is synonymous with Gitaly server.
Almost.
Almost, okay. Like if I wanted to, could I just like have several Gitaly servers run on the same like physical storage, and then the Gitaly server just has its own namespace for where it stores things?
So historically, a storage was just a mount point, so a subdirectory somewhere on the GitLab server.
Okay.
And because we wanted, well, actually, you see it exactly this. This is outdated, but this picture sort of ignore what Git data dirs is. That's from Omnibus. But things would have looked like this, perhaps, in the old situation. And when we introduced Gitaly, we wanted to have an option where we say we run Gitaly close to on the same server as the Rails application, and we don't worry about these mount points. So then one Gitaly process would have to serve all these 3 things at the same time. So within Gitaly's config file, you can define multiple storages that it serves.
I see.
I don't know how to explain this clearly. It's too much flexibility for our own good, to be honest, but we were sort of ended up here because of the way we had to transition from the existing situation.
I see. So in the repository model, there's like the storage field.
Yeah.
So does that map to the earlier page where it like storage mapped to a Gitly server, or the Gitly server's storage?
Let me show you exactly what it maps to. Okay. This is defined in the config file. I think if I search for storage, I'll find it eventually. Please. Yes, here we go. I don't know why this is called advanced, but this is where it's defined. So there's a subsection repositories, storages, and this is an array of hashes. No, it is a hash. This is a hash key. This is YAML. I have to think for a moment about what it means. This is a hash called storages, and it has entries, and this one has only 1. If there would be another one, it would look like this. This path field is legacy stuff, so let's for the moment just delete it because you don't actually need it. So this is all you really need. Storage needs to have a name, and these are the fields that get stored in the projects table on that column. So if at runtime you would load a project and it has a value in that column that is not known from the config file, that will be a runtime error that you only find out about when you hit that record. Because there's no way for us to validate when the app starts up that all projects in the database have a valid storage field. And this thing has to have at least have a Gitly address, which in this case is Unix Socket, and it is valid for multiple of these entries with different names to be behind the same address. But then within Gitaly itself, okay, let's maybe contrast that. So in Gitaly itself.
Oh, so two storage in this config can actually point to the same Gitaly server.
Yeah, same Gitaly process on the same Gitaly server. Now, if you look
Okay.
at an example Gitaly config file, this has its own definition of storages, and this is a map from. So let's see. Let's take this example. So we had default and then storage 2. So then I would define a second one here.
I see.
And I think the way things work now in Gitaly is that we yell at the user, or we abort at application boot time if these things are not
If there's a mismatch.
at
Okay.
this point.
Oh, I see.
Although maybe it's allowed. I don't remember exactly. And if you look at the picture again, you can sort of see what happened here, right? Because this was the old situation: name path in GitLab's config, and now in GitLab's config it is name Gitaly address, and then in Gitaly config we say name path again.
Right.
And this is exactly how we were. Go ahead.
Yeah. So I was going to ask, in the case where if one Gitaly server has to like do something in a repository on a separate, like on a different storage, and that storage doesn't live locally, then it has to make a network call. Does it kind of like figure that out?
These paths all have to be local on the Gitaly server.
Oh, they do. Okay. Okay.
Yeah. I mean, if they're NFS, they're not strictly local, but from an application point of view, these are local file system paths.
But what I mean is, like, what if in this situation, okay, so what if storage 2, the Gitaly address was something else?
Yeah, I'm going to do that now.
Okay.
So let's say, suppose we had this, right?
Right.
This implies that there is a second Gitaly process running with its own unique config file. So the first Gitaly process would have this config file, and then the second one would have, in its config file, it would have this, no, come on, this with name storage 3, and this can be anything.
Right. Right. So if this Gitaly server, like for instance, needed to do a clone from a different storage, then like it would have to make a network call.
It will make
to
a network call.
The different Gitaly server.
Yeah, it is one of the assumptions of Gitaly that each Gitaly process, so each Gitaly server can make network calls to all other Gitaly servers.
Right. Right.
They have to be arranged in such a way, otherwise nothing works. For instance, when you make a fork of a repository, right now that is a naive full clone, and because we don't know where the other repository is, we just default to making a network call to whatever the Gitaly server hosts the original repository and doing a clone like that.
Okay. Makes sense.
And this, yeah, exactly how this network call works is very interesting, but we should probably not go into it now.
Okay.
Well, unless you both want to, but I think
we can move on.
Yeah, I think we can focus. There's more to explore on how stuff works here. Paul?
Regarding the, we're using Unix addresses here for a local socket, a file socket. Yeah. So what happens when the Gitaly server is on a different machine? Are we forwarding that to a TCP address, or do we replace this config file with a TCP address?
Yeah, we write different addresses here. Let me go back to the docs. Gitaly. Oh, here's some stuff about the network architecture and the storages, by the way. So this repeats some of the stuff I was just talking about. And let's see, addresses. Okay, this is not very clear, but we allow addresses that look like Unix colon something, and we have defined this custom made-up scheme where you can say TCP colon // and then you get an unencrypted. Well, what it really is, it's a gRPC connection, so that's HTTP/2, but it's an unencrypted network connection. And since 11.8, you can also use TLS colon // and then it will use encryption. And I think the way things are currently deployed on gitlab.com is that these machines are all firewalled and they use the unencrypted variant. There is also a token mechanism where each server may have a token. You can also see that here in the example config file that you can set a token per Gitly server. And at the beginning of each RPC call, we transmit the token to prove, the client transmits the token to prove that it's the client, that it has access. It's a very basic authentication mechanism. So yeah, that's sort of the root of looking at how things work coming in from the config. So we've now touched on the SQL model, how repositories are stored in the database. Well, not because they hang off of the projects really. And the mapping between storages and Gitaly addresses and the confusing ways they can overlap or cannot overlap. Maybe we can move on, unless we want to know more here. I can show you something about the actual client code in the Rails application that makes gRPC calls.
Sure.
Okay.
Cool.
Let me close this. Let me close this. It's going to complain that I'm not saving, and I don't care. Okay. So some basics of the layout of the Rails application. Most Ruby code is in either in app or in lib. I don't know exactly where this, understanding what is app and what is lib is part of figuring out why the hell Rails is organized the way it is. Within app, there is the models directory, and these things map to SQL tables for the most part. Not necessarily, but almost all of these correspond to SQL tables. So they are, yeah, I guess active record is the actual name of this pattern. So in here, you have the project class, and the project can have an associated repository. And this is actually a good example because project here is an active record class, meaning that it has a SQL counterpart, and repository does not. But it is still tightly coupled to the rest of the Rails application code. So this is the first layer you often hit when dealing with repositories in the GitLab code base. If you reason from the view, if you start from the point of view of here's some application code that wants to do something, they first have a project instance, and then they can say project.repository, and then they get one of these things. Now, repository has a role repository. I think that's what it's called. Let's look. Yes, role repository. And role repository is an instance of something called GitLab Git repository. And GitLab Git repository is in a different directory. So these guys are in app models. GitLab Git repository is in lib. Now, this thing started out as a sort of adapter between GitLab, the application, and however we were accessing Git repositories. Before we had Gitaly, we used Rugged a lot, or we spawned Git process directly. Before that, we used before we used Rugged mainly, we used a gem called Grit. And GitLab Git, throughout the history of GitLab, has been a sort of adapter between the Rails application and however we really interact with Git repositories. So when we did the Gitly migration, we kept this adapter. But this thing is not actually making Gitly calls because it worked easier for us to not write all that code in here, but to write it next to this. So next to this, we have lib gitlab GitalyClient. And this is the actual gRPC client code. So when GitLab interacts with the repository, first it has to fetch a project, which is app models project. Then through project, it accesses a repository, which is app models repository. Then from there, it needs to access lib gitlab git repository, which sometimes happens transparently, which is very confusing because in Ruby you can have transparent delegation and, well, there's no strict typing. So app models repository, lib gitlab git repository, and then the actual gRPC calls get made here in this lib gitlab Gitaly client thing. Are you still with me? So during that customer crisis,
yeah, we swapped out some Gitly calls for rugged calls. Did that happen here, or did that happen in on the? Cause I know on Gitaly we also have like a Ruby sidecar.
No, that happened here because this this directory is where we used to do interact with rugged. Rugged calls used to live here, and there were some rogue bits of code otherwise otherwhere in the application, other place in the application that would also call rugged, but officially rugged calls happened here. So these patches that are now being discussed to bring back rugged calls are modifying this code so that instead of calling out to Gitaly clients, it will call out to rugged.
Got it.
Okay. So cool. Good question. Yes, yeah. So, okay, I'm taking the long way around before I show you the actual gRPC stuff. Forgive me for that. All the main stuff happens in this file, GitalyClient.rb. This is a generic gRPC client that is, well, it's generic with respect to all RPC calls that exist within the Gitaly protocol, but it's specific to Gitaly. These other classes are subdivided by RPC services as they are defined in the protocol. So these do things like, okay, I'm going to keep doing this roundabout thing. Let's look at commit service. This will have a find commit somewhere or find all commits. So this is an example of glue code where we built. This is us directly using gRPC and protobuf code, right? This creates a protobuf object in Ruby with some field sets. And then it does GitalyClient.call, which is the magic that we have yet to come to. And it gets a response object, and then it parses the response. And then these things get parsed again in the lib gitlab git layer. So for each RPC, we have some glue code that takes some inputs from Ruby and then sets up the actual RPC messages needed to make do the request response. So shall we move on to this one, to GitalyClient.call? Cool.
Sure. Yeah.
So here we go. This is a big class. Let's see. Let's look at call first. Maybe that's, I haven't thought about how to talk you through this class.
I remember looking at this and being confused.
Yeah, it's a bit big, so that's a natural reaction. Here's call. So this thing, let's see what's going on here. It takes the storage, I think that's the storage name. the service and the RPC. So that's us abstractly saying we want to use commit service and we want to call the find commit RPC. It takes a request object and forget about this for the moment, and it can take a timeout. So then what we do? Well, taking the start time, this is just for monitoring. I have no idea what request hash is for. This has to do with tracking the number of Gitaly calls, RPC calls that happen within the scope of one web request, and to make sure that we don't make too many. So we can ignore that as well. Then we are assembling some keyword arguments that we will need later based on the storage, the timeouts, and the remote storage that I said we were going to ignore. So what does this thing do? Request keyword arguments. Okay, it sets authorization as metadata. This is the only way we can inject, we're injecting a header field, which is almost an HTTP header field into the call. And we have to use a keyword argument hash for that. This is all metrics, observability, so we don't care. Timeouts. Okay, here we compute a deadline from the timeout, and we set that on that hash. So what comes out of this is something that has some metadata, which is there mainly for authorization. It has some stuff for metrics and tracing, and it has a deadline. So that's what this thing is doing. And then we look up the stub for this service and storage, and this, then we do a dynamic method call in Ruby with the RPC and the request and the keyword arguments. So RPC in this case might be, okay, so service might be, let's say service equals commit service. Let's say storage equals default. And let's say RPC equals find commit. These are Ruby symbols I'm typing, which are the usual way to refer to methods. If you want to abstractly refer to a method you can call, you type it as a symbol. And the keyword arguments, so keyword arguments was something like the Ruby hash with metadata, authorization, blah, deadline, some, okay, I'm also going to say blah. So that's what would be the keyword arguments. And this thing is taking care of the reuse of stub objects. So stub objects are how gRPC wants you to make gRPC calls. So if we would make a gRPC call by the book, it would look something like this. We would say stub equals gitly commit service stub.new and then address. Let's forget about TLS. Credentials. Stub.find. Okay, I made a mistake here. This is actually spelled like this. Find commit request. This is what things would look like naively. They are more complex because these stub objects establish a network connection to the Gitaly server, and we don't want to create a new one all the time. So we cache them globally across the Rails process we're in. So that's what this method is doing. This method is going somewhere up here. Come on, where are you? Okay, it's using a mutex. It goes into a hash. It looks up by storage and by service. It looks up a stub object and it returns that thing. But there's really nothing to it except that we don't want to throw away that object all the time. And yeah, and then there's stuff in there like what are the credentials, what are the address, and that all has to be looked up, which is just, if you look at it in isolation, it's not very complex. It's just that we have to pull all these things together and they're broken down into these methods. So this would be the stub, and instead of, so this is a method call. That's not something we can do dynamically. Oh, and we need to pass the keyword arguments, which is these headers. So this is what it would look like naively, and because we can't, because we want to do this dynamically for whatever RPC we are dealing with, this becomes an under send like this. So we do that like this, and then this find commit thing is a variable, so that's this variable here. Is this sort of making sense?
Yeah. So in the stub class method, is that where it actually talks to the Gitaly proto gem to find the?
Yeah, it needs to find this thing.
There's like a new RPC, right?
So,
right.
So this is the other problem, that we want to dynamically retrieve this Ruby object. And
right.
We do that by calling, well, that's the stub class method. Let's look at that for a moment. So it goes to the Gitly namespace. It says const get, and then
oh, okay.
it does some magic on the input. So actually I got the input wrong. So I wrote that it was this. I wrote this commit service, but actually that's wrong. The input is this, and then that becomes a string, and then that gets camel cased, meaning that this becomes an uppercase. This thing goes away, and this becomes uppercase, and it looks like this. So that's camel case, and then it goes back to symbol, and then it becomes this. So then actually you end up with that thing. And that constant is then dynamically retrieved here at runtime. And then we're in a new namespace, and that namespace has an object called stub. And that's how we get the stub. So crazy runtime Ruby dynamic fetching, whatever stuff. Well, crazy if you're not used to Ruby,
yeah.
but
Ruby magic.
It's the best way we could come up with making this somewhat succinct without having to do code generation. Because now we can have those other classes like I was showing you the find commit. Okay, this is a complex example, but okay, this is the real find commit. So this does .call, and so this will be a string like default, and it can just abstractly name the service and the RPC and the request. So all this meta programming stuff is to make these lines simple. So we can have just one .call function that we can make all the calls with.
So this is a bit of a digression, but so with feature flags, is that something that the client passes in through the keyword arguments, or somehow it gets into the header of the gRPC call?
There are different kinds of feature flags. We usually, when we're talking about feature flags, we mean client-side feature flags. And
right.
Then the feature flag just controls a call gets made or not. So in that case, nothing gets passed. We did set up the infrastructure to have server-side feature flags where we can communicate from the clients, so from here to Gitaly, that we want Gitaly to have optional behavior. And in that case, that gets passed in somewhere through the .call method here.
Okay.
And that would be like a gRPC metadata in the header, right?
Yeah, exactly. Then we set metadata here, and it gets parsed again. Like you can then call a method on the context, the request context on the go side, and get the metadata out again.
Right. Right.
Yeah, so we
Okay.
could switch between possibly the Ruby implementation versus the Go process, subprocess implementation.
If we wanted to do something like that, we could do that. We only used this once, so it is not completely mature. One thing that is notably missing is that this is not the only Gitaly client. This is a very big and important Gitaly client, but it's not the only one. And so Workhorse, GitLab Shell, Elasticsearch Indexer are also Gitaly clients. And if we want to have these server-side feature flags, they would have to be propagated from here down to Workhorse and then back up into Gitaly. And that propagation doesn't happen yet. So you cannot control the metadata that Workhorse is setting on its Gitaly calls to get feature flag behavior on the Gitaly server.
Right.
If we want to, we may have to build that out at some point. It's just not there yet. That was very complex.
So is that because Workhorse is communicating to Unicorn via like a regular web request? It's not using gRPC context, that sort of thing, where those headers can get relayed back?
No, exactly. It is using side channels with just regular JSON data. So we would have to explicitly in that side channel encode, hey, we want you to set some extra gRPC metadata, and that isn't there yet.
So theoretically, if like everything used gRPC, we'd be able to just modify the context and that information would get relayed back to the caller.
I am not sure if the way the requests flow get things propagated in the right direction, because Unicorn does not make gRPC calls to Workhorse. So Workhorse is the initial, well, it depends. You know, this is a big topic, and I don't think we should get into it because we set aside an hour for this, and the hour is almost up. So I think it would be good to try and wrap this up and see if there's something else.
Sounds good.
We want to know. Thanks. We want to know about this file. So I've talked you through somehow most of what GitalyClient.call does, and there isn't much else going on here. I mean, a lot of this has to do with metrics and observability and like putting tags or counters and just keeping track of what's happening with Gitaly calls. And we can do that because all Gitaly calls in Rails get initiated, go through this class, which is a nice strength to have. But the downside is that this class keeps getting more complex as we add more metrics and things. Which is why it looks the way it does today. Yeah, so here's the server feature flag thing. I don't think I should even start looking how that is set up. Yeah. Oh, and the other thing we do with the Gitaly client class is that it has this feature enabled methods, which is just a really thin wrapper around this generic feature flag thing inside GitLab. So if we make a client-side change like the commit finder we were talking about, we would have a feature. We would probably gate that by saying if Gitaly client.feature enabled commit finder, and something like that would then hit this method and would translate commit finder into Gitaly underscore commit finder, then look that up in the SQL database and take it from there. And there's some nice stuff in this class because you can have features that are enabled the percentage of the time. So you can send a percentage of traffic. It gets randomly chosen if the feature is enabled, so you can ramp up the use of a new feature. But all that logic is not in this file, fortunately, because this file is complex enough already. What else is in here? Yeah, this is all about counting calls. Count. Yeah, timeouts. Yeah, so this stuff is interacting with the the current settings, current application settings. That is that thing I showed you in the database. Do I have that up? Settings, preferences. Now this thing is called. No, it's okay. So these fields, fast timeout, default timeout, medium timeout, they get queried here through this thing. And this uses, I think this thing gets expired on each request, but then during the request it's cached, so you can do these config lookups without hitting SQL 100 times. So that's what this thing is doing. Then there are more call counts, and then that's the end. Well, it's 5 o'clock. I think we should wrap it up. Anything else you want to ask before I stop screen sharing? That's a no.
Nope.